We are in the next topic of the calculus, which is very important. It's going to be about the derivative of the function. So in this topic, we're gonna talk about the tangent line that I introduced you last time. So we have the tangent line, the derivative of the function, the derivative of the constant function, derivative of the power function, derivative of exponential function, and we're gonna dip the trigonometry functions. So in this handout, we're gonna study the first two first. So it's gonna be 2.7 and 2.8, and we're gonna continue 3.1, 3.5 later. Okay, so this one will be the thing that cover on this handout. The first thing that we're gonna talk about is going to be about the tangent line and the derivative. So the tangent line that we discussed before about the introduction to calculus will be just the tangent line problem. The tangent line problem asks you to find the tangent line. So you are having the curve y equal to fx. So you have the curve y equal to fx and the tangent line problem, which is to find the tangent line to the curve at the point P. So you like to find the equation of this line. In order to find the equation of this line, you recall that this guy has equation y equal to mx plus b, and m here denote the slope of the tangent line. Okay, so this one will be the thing that we normally call the slope of the tangent line. And in order to find the slope of the line, we need 2 points. So we have only 1 point here, which is P. We don't have the another point on the tangent line that we know because it's not on the graph, so we cannot predict it yet. However, if you have another point Q on the curve, okay, so you'll be able to determine another point Q which is on the curve, and we draw the thing that called the secant line. So this guy is called the secant line that I already discussed in the introduction. And you'll be able to find the slope of this secant line. So the slope of this secant line MPQ equal to FA plus H minus FA over H that we have seen before. And the tangent line will be about limit H go to 0. So we're gonna move this Q close to P, and we're gonna move Q by taking the limit. And I discussed you about this topic before that we can have Q on the right side, or we may have Q on the left side. So it's going to be the limit of both sides. So it's going to be limit h go to 0 of fa plus h minus fa over h. If this limit exists, it's going to be the slope that we are looking for. So this one will give you the slope of the tangent line that we are looking for. Okay, so this limit, if this limit exists, this guy will give you the slope of the tangent line to y equal to fx at the point P. The next one, that sometimes this limit kind of difficult to compute because normally this function fa plus h is not easy to find. Okay, so when you like to find this value, sometimes it's kind of difficult. So we're gonna change the variable in order to ease the calculation of the limit. We're gonna let a plus h equal to x. So we're gonna let a plus h equal to x. So in this case, your a plus h turn out to be x. Okay, and your h turn out to be x minus a. So you have h here, it's turned out to be x minus a. And when h approaches 0, when h approach 0, it means that x will approach a. So h approach 0. So you see h approach 0, so this guy disappear, right? So you see that x will be equal to a, or x will be approached to a. So in this case, the yellow guy will change the bottom guy here also. So this limit fa plus h minus fa over h can be written in the form of limit x go to a of fx minus fa over x minus a. And this one, you see that you not have the complicated term to compute, and it will be easier in the calculation of the slope. So this guy, the slope of the tangent line at x equal to a, will have a special name or another name. Another name that we're going to use for this important number turned out to call the derivative of f at x equal to a. Okay, so the derivative mean slope. So this guy had the same meaning. So the derivative or the slope is the same thing. It's going to be slope of f at x equal to a, or the derivative of f at equal to a. And this guy, you have a prime a. So the notation here is called prime. Okay. Or you may use the notation. So f prime a is the Newton notation. So this one is the Newton notation, and you're going to have the Leibniz notation. So you have two kinds of notation, the Leibniz notation or the Newton notation. The Leibniz notation, we read this guy as dy dx, dy. So it's going to be dy dx. It's not going to be dy by dx or anything that you may have heard before. I'm going to just say dy dx. So it's going to be dy dx and df dx. So for this guy, it's going to be df dx. Okay, normally we're not going to say dy by dx or something. So it's going to be dy dx. Okay, so I think the thing that you may have heard is going to be wrong. So you just I'm gonna just say dy dx. Okay, so that one is going to be, actually it's gonna sometime you may have here dy over dx. This one is also correct. Okay, dy over dx, that's also correct, but dy by dx not correct. And this will be the limit notation that we will use for computing derivative of the function f at a. So it's going to be limit h go to 0 of fx plus a, not f, sorry, f a plus h minus fa over h, or the limit x go to a of fx minus fa over x minus a. This one is going to be easier. I would suggest you memorize this guy. So this one is easier to use. Okay. However, this one will be easier for for deriving the formula. Easier for deriving formula. Okay, so it's gonna be two advantage. So you have two formula. This one will be good for deriving formula, easier. So the next, the another one is gonna be easier for getting the value. So they both have advantage on the calculation. The notation, okay, we're going to use this one for the whole calculus thing. It's going to be f prime a, it's going to be dy dx, it's going to be df dx. And if you like to indicate the point, you're gonna use the bar and x equal to a to indicate the point that you are finding derivative at. Okay, so the question asks you to find the slope. Okay, so the slope of the tangent line to the curve y equal to 2x squared at x equal to -1. So for this question, we would want the slope m to be dy dx at x equal to -1, okay? And you're gonna find the limit, okay? X go to 1, not x go to 1, go to -1 of fx minus f -1 over x minus 1. And in this case, your fx turned out to be 2x squared. So you're gonna have limit x go to -1 of 2x squared minus 2 -1 squared over x plus 1. And you see that this guy, you see you can have 2x squared minus 2 over x plus 1, okay? And this will be limit x go to -1, and you have 2 outside, and you have x squared minus 1 over x plus 1. And this guy will become 2x plus 1 x minus 1 over x minus 1. And you're gonna cut x minus 1 on top and x minus 1 on the bottom. And this will be limit x go to 1 up to x plus 1. So it's gonna be 2. Sorry, I make mistake. So this guy, let me erase this one. So this one is 2x plus 1 on the bottom. So in this case, you're gonna get rid of x plus 1 here. So it's gonna be x plus 1, x plus 1. So it's gonna be 2, and you have -1 minus 1. So it's gonna be 2 minus 2 equal to -4. Okay, so you have the slope of the tangent line equal to -4 in this case. Okay, so you see the procedure will be you have first to memorize this formula, and you plug in fx. So you have your fx, which is 2x squared, so you plug in, okay, and you have f minus 1 on top. And then you simplify by using the factoring technique that we looking for the limit before. Okay, so this one is not that hard to do. The next one, you like to find the derivative. Now it's going to be the derivative of fx equal to root x at x equal to 9. So you're gonna have f prime 9. So you use the formula limit x go to 9 of fx minus f9 over x minus 9. Okay, and this one is going to be limit x go to 9 of square root x minus square root 9 over x minus 9. And you may just simplify this one a little bit, so you get root x minus 3 over x minus 9. So you're gonna multiply root x plus 3 on top, root x plus 3 on the bottom, and this will allow you to get x minus 9 on top. So this one will be x minus 9, and on the bottom you will get x minus 9 and square root x plus 3. So in this case, you're gonna have square root x plus 9 So this guy will be cancel each other. So this guy and this guy will be disappear, and you gonna just get limit x go to 9 of square root x plus 3. So it's gonna be 1 over root 9 plus 3. So it's gonna be 1/6. Okay, so this limit equal to 1/6. You may ask me that, hey, why don't you just differentiate and you're gonna just like a 1 over 2 root x. Okay, so this one, if you study calculus in high school before, you may ask me, can we just f prime x equal to 1 over 2 root x and f prime 9 equal to 1 over 2 root 9? So it's going to be 1/6. Is it correct? Yes, this is correct, but we don't have the formula yet. Okay, so we're gonna derive the formula later, and we're gonna use the formula to differentiate. But now we are using the definition. Okay, so this one is going to be using the definition, the limit definition. So if the question asks you to use the limit definition, this is the correct way to do. Okay, so use the limit definition. This one is the way to use the limit definition in order to find the derivative. Okay, so if the question asks you to just differentiate, so it's going to be here. Okay, 2 lines. The next one, you like to find an equation of the tangent line to the curve y equal to x plus 1 over x minus 1 and x equal to 4. So in this equation, you're gonna have to find the tangent line. So in order to find the tangent line, we shall need slope. Okay, so we shall need slope and 1 point. Okay, so we shall need slope and 1 point. The slope will be derivative. Okay, and 1 point will be the 1 point on the curve. So it's going to be x equal to 4. Okay, so x equal to 4. You're going to need y equal to 4 plus 1 over 4 minus 3. So it's going to be 5. So the point will be 4, 5. Okay, so you have the point 4, 5 in this case. Okay, so we have to find the slope of the tangent line to the curve. We need the slope, which is the derivative. So next, we compute the derivative at 4 to be the slope m. Okay, so it's going to be slope. Okay, so in this case, you're gonna have f prime 4 equal to limit x go to 4 of fx minus f4 over x minus 4. So this guy will be limit x go to 4 and fx is x plus 1 over x minus 3 minus f4 equal to 5 over x minus 4. Okay, so to have this one, and you need to simplify. Okay, so we're going to simplify this one in order to compute the limit. Okay, so in this case, you see that you may combine the top part. Okay, so this one is your fx. Let me highlight this one a little bit. So it's fx and minus 5 over x minus 4. So you get this guy is going to be limit x go to 4. Okay, so limit x go to 4 of fx. So it's going to be, you're going to combine the top part, the bottom part, and just copy it down. So you get x plus 1 minus 5 x minus 3 and everything is over x minus 3. Okay, so you will get limit x go to 4. Okay, so this function on top turn out to be x plus 1 minus 5x plus 15. Okay, so it's going to be x plus 1 minus 5x plus 15. And over x minus 3. So you combine this guy, so you would get negative 4x. Okay, so it's going to be negative 4x plus 16. Okay, and you have x minus 3 on the bottom, and you will get x minus 4. So x minus 4 stay on the bottom. Okay, and the red term come down, so it's going to be negative 4x plus 16. And you see that this guy will be negative 4x minus 4. And it's going to be x minus 4 and x minus 4 cancel. So you plug in the value for this limit. It's gonna be, okay, let me use this space. So it's gonna be negative 4. Okay, so it's going to be negative 4 over 1. So it's going to be negative 4 for your slope. So this guy become negative 4 over 1 equal to negative 4. Okay, and this guy gives you the slope of the tangent line. Okay, so this one will be the slope that you're looking for. Okay, and you're gonna use the point. Okay, so the point equal to 4, 5, the slope equal to negative 4. And you're going to use the thing that called point slope form. The point slope form gives you in the way that you have y minus y0 equal to mx minus x0. And the slope here is the m, and the point here is your x0, y0. Okay, so this one is the point slope form, and you will get the tangent line at x equal to 4 is, okay, so it's gonna be y minus 5 equal to m, which is negative 4, x minus 4. Okay, so you have m equal to minus 4 and y minus 5. So in this case, so you have y minus 5 equal to negative 4x plus 16. So you get y equal to negative 4x plus 21. Okay, so this one is the equation of the tangent line that we have. Okay, so this one is this example. Another example, okay, let me wait for you to copy and you may have the whole question. Okay, so for this one, you have the slope, point slope form. You need to know this one in order to find the tangent line. Okay, so you have the point slope form y minus y0 equal to mx minus x0, and you'll be able to apply this thing to find the tangent line. The next example, I will teach you to find the derivative of the piecewise function. So this guy we are discussing derivative of piecewise function. When you are having the piecewise function like this, and normally the question will ask you to find derivative at the point that the function break. So you see that the function break into two formula and it's breaking at x equal to 1 in this case. And the question asks you to find f prime 1 if it exists. The thing that you're gonna use is gonna be just the basic formula for derivative. So it's gonna be, you need f prime 1. Okay, so we're gonna compute limit x go to 1 of fx minus f1 over x minus 1. Okay, so in this case, you see that this one will be limit x go to 1 of this function. Okay, so let me take screenshot. Sorry, I should have done this one. Sorry, I gonna just take the screenshot for this one only. Shoot, yes, it's gonna be copy, and then I'm gonna paste this thing. Okay, so you see that this is your fx. Okay, so this is your fx. Let me erase something out. I don't need this semicolon and I don't need the full stop. Okay, so this one is my function, and then I gonna subtract. Okay, this one I gonna subtract by f1. What is f1? f1 here, you use the top formula, so it's gonna be 1 plus x squared. Sorry, 1 plus 1 square. So it's going to be equal to 2. Okay, so you're going to subtract by 2, which is f1. Okay, and it's going to be everything is over x minus 1. And you see that we have two formula. So this guy turned out to be limit of piecewise function. We get a limit of piecewise function. Okay, so we get a limit of piecewise function. In order to compute the limit of piecewise function, we gonna do what? We gonna use, so we use left, right limit. Okay, this is the technique that I taught you before. Okay, so the technique that we taught is gonna be, you have like a, what is called plug-in simplify, and you're gonna have left right limit, you have squeeze theorem. Okay, and you gonna use the left right limit in this case, so it's gonna be the left right limit. Okay, so you're gonna have the yellow function and the pink function. Okay, so I'm gonna compute left limit and right limit. So you're gonna compute limit x go to 1 from the left. Okay, so limit x go to 1 from the left, is going to be the pink guy. So it's going to be 3 minus 1 over x minus 2. Okay. And this guy is over x minus 1. So you are in the pink case. Okay. And you compute this limit. Okay. So you compute this limit. So it's going to be limit x go to 1. And you combine the top. So the top can be combined to obtain 1 minus 1 over x. So this guy will be x minus 1 over x. And it's going to be over x minus 1. Okay. And you see that you'll be able to get rid of x minus 1. And you just plug in x equal to 1. So it's going to be 1. Okay, so it's going to be 1. So this one is limit from the left side. And we're going to compute the limit from the right side. So we have this one, and we're going to compute the limit from the right side. Limit x go to 1 from the right. And it's going to be the yellow guy. So it's going to be 1 plus x squared minus 2. So this one is 1 plus x squared minus 2, okay, over x minus 1. So in this case, you get x squared minus 1 over x minus 1. And you factor this guy as x minus 1, x plus 1 over x minus 1. And x minus 1 and x minus 1 get rid of. So let me mark it by something like this. Okay, so we cancel both of them out and you get limit equal to 2. Okay, so you have limit on the left side. I make mistake. The left side and the right side, sorry. So this one is positive. This one is the right side, sorry. And this one is the left side. Okay. So you have the limit of the left side equal to 2. Okay. So it's going to be x plus 1. So you see that you have limit from the left equal to 1. Limit from the right, sorry, limit from the left equal to 2, limit from the right equal to 1. Okay, so this one are not the same. Okay, so you get limit x go to 1 from the left of fx minus f1 over x minus 1 not equal to limit x go to 1 from the right of fx minus f1 over x minus 1. Okay, so this limit equal to 2. Okay, so you have the limit, this guy equal to 2. So this guy equal to 2. This guy equal to 1. Okay, so you have 2 not equal to 1. So you're going to say that f prime 1 does not exist. Okay, so you're going to say that f prime 1 does not exist. So this one is the how we find the derivative of the piecewise function at the given point. Okay, and normally it's gonna be at the point where the function separate into other formula. for the next one, you have fx equal to 2 minus square root x squared plus 4. And when x less than or equal to 0, and fx equal to x cubed minus x squared when x is more than 0. And you like to find whether f prime 0 exists. So for f prime 0, it will be limit x go to 0 of fx minus f0 over x minus 0. And so in this case, it's going to be limit x go to 0 of your fx. Your fx turned out to be two formula, 2 minus root x squared. Okay, let me crop this guy. It must be easier. Okay, so for this one, you get your function like this, and it's going to be minus f0. So minus f0 equal to 0 cubed minus 0 square equal to 0. Okay, and so you get 0 here, and everything will be over x. Okay, and you see that you have piecewise function. So you have gonna have the top guy and you're gonna have the bottom guy like this. So you're gonna have to find this limit by the left right. So we're gonna use left right. Okay, so you're gonna use left right limit. In this case, you're gonna have limit x go to 0 from the left. It's going to be the pink formula. So it's going to be 2 minus root x squared plus 4. Okay. Root x squared plus 4 over x. Okay. So this guy will be the pink formula. And you're going to have to multiply by 2 plus root x squared plus 4 over 2 plus root x squared plus 4. So this one will become limit x go to 0. Okay, it's gonna be 4 minus x squared plus 4 over x. Okay, and this guy will be x squared over x. Okay, so it's gonna be negative x, and the limit turned out to be equal to 0. Okay, so this one will be this limit from the left side. Another guy will be limit from the right side of 0. So it's going to be the yellow formula. So it's going to be x cubed minus x squared. Okay, minus 0. So you not have anything, and it's going to be over x. So this guy is the yellow formula. Okay, and you're gonna have limit x go to 0 from the right, and you get x outside x squared. So it's going to be x minus 1 over x. So it's going to be x minus 1. So it's going to be 0. 0 minus 1 equal to 0. Okay, so this one is taking the limit equal to 0. So you see that the limit on the left side equal to the limit on the right side. So these guys are the same. Okay, so you're gonna be able to conclude that limit x go to 0, which is f prime 0, equal to limit x go to 0 of fx minus f0 over x minus 0 equal to 0. Okay, so you'll be able to conclude that this one exists and equal to 0. Okay, so this is how we compute derivative of the given function. Okay, and this is the thing that you have. For this one, it's going to be piecewise function that you have to use the left-right technique. Okay, so you have to use the left-right technique in order to compute the limit. For the next example, you have fx equal to absolute x. Okay, the first question asks you to graph the function. So it's going to be, you have this one and you are asking to graph fx equal to absolute x. What is absolute x? It's going to be x if x greater than or equal to 0. It's going to be negative x if x less than or equal to 0. So you're going to get y equal to x if x positive. Okay, so it's going to be y equal to x if x positive and y equal to negative x if x is negative. Okay, so this guy will be the pink guy and this guy will be the yellow guy. Like this. Okay, and you're gonna have y, you're gonna have x here. Okay, we like to determine whether the function is continuous at 0. So what we can see from the graph will be, you have from the left side, the limit turned out to be 0. From the right side, the limit also turned out to be 0. And you have f0 equal to 0 also. Okay, so in this case, f is continuous at 0. Okay, for number 1, for number 2, okay, limit x go to 0 of absolute x is going to be absolute 0 equal to 0 equal to f0. So f is continuous at x equal to 0. Okay, so this one will be just this continuity. The next one will be determine if f prime 0 exists. Okay, f prime 0 will be limit x go to 0 of absolute value of x minus absolute value of 0 over x minus 0. And this will become limit x go to 0 of absolute x over x. And this guy, you see that it's going to turn out to be piecewise function because absolute value of x, you have x if x positive, and it's going to be negative x if x negative. And actually, the x cannot be 0. Okay, and cannot be 0 because you have x on the bottom as well. Okay, so you see that you're gonna have to use left right. So you have limit x go to 0 from the left. It's gonna be negative x over x equal to negative 1. And you have limit x go to 0 from the right side equal to 1. Okay, so you have left not equal to right. Okay, so you have limit x go to 0 of absolute x over x does not exist. Okay, so you get f prime 0 does not exist. Okay, let me explain you a little bit. So for this one, you have x positive. Okay, so you are in the right case and you are in the left case here. Okay, so you have the left limit does not equal to the right limit, and you have the limit does not exist in this case. However, this function is continuous at 0. Okay, it is continuous, but the derivative does not exist. However, if f prime exists, the function will be continuous at x equal to a. Okay, so we're gonna have an important remark that if f prime exists, okay, if you be able to differentiate, the function will be nice. Okay, so if f prime exists, it's implied that f is nice at x equal to a. Okay, so when it is nice at x equal to a, it's gonna turn out to be continuous. Okay, I'm not gonna prove this one for you, but I like to mention that this example show that sometimes you get continuous function that is gonna not be able to differentiate because the thing that you can see is gonna be at 0. Okay, we obtain a corner. Okay, so we have a corner or at x equal to 0, and this corner will give you no tangent line. What does it mean the corner will give no tangent line? You can see from the next page. If you have a corner like this one, you see that you can touch the point P by many lines because it is a corner, so it can be rotated. Okay, so this one, you see that you have many tangent line to this point. So it's not gonna be differentiable, so you not be able to find derivative of this function. Okay, and sometime, so this what are this? It's going to be when does the derivative at the point not exist. It means that you have a corner. The corners come from you have this one to this one to graph like this. Another thing is going to call cusp. Okay, so this one is called curve because it's gonna be two curve that is gonna be meet in this way. So it's not gonna be a corner because the curvature of the curve. Okay, I use a fancy one. It's called the curvature of the curve here, like a meet in this way. Okay, so you're gonna use your finger like this one. This one is called cusp, and this one is called corner. Corner is gonna be like the angle that two curve make. However, if you have the curve that going to this point at in the same curvature that like this, it's gonna be like this. Okay, so it's gonna be like this. Okay, so in this case, it's called cusp. This one is called corner. Okay, so the picture quite clear. And this one you have no derivative as well because you can touch P in many line. Like this is not going to be a unique line. Another one is going to be the vertical tangent line that the limit of the 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 thing that we use for the definition of the derivative turned out to give you negative infinity or positive infinity. So this one is going to be the tangent line. And finally, it's going to be when you have a discontinuous function, you're going to have many tangent line. So in this case, it's going to, in this four picture, it's going to be when does the derivative of the function at a point does not exist. Okay, let me conclude everything. Okay, so for the thing that we have learned here, we have the technique in order to find the limit. Okay, so we learn the technique in order to find the limit. Let me correct one mistake. I think about that already. So we have one mistake on the calculation here on the continuity. Okay, so let me fix that a little bit. The question asks you to be continuous at x equal to 0. Okay, so if x equal to is continuous at x equal to 0. So I make a mistake here. It should be f is continuous at x equal to 0. Okay, so this one should be 0. It's on page 31 of the limit handout. Okay, it's on page 31 of the limit handout. So this one, it should be x equal to 0. That's the mistake that I made. The thing that I want to mention will be, you see that we have 4 way to compute the limit. The first one is using graph. The second one is plug in simplify. And we use left right limit in the case that the function is piecewise function. And we have squeeze theorem. And today we discuss how to find derivative. When you find derivative, you see that sometimes, like a piecewise function, you need to use the technique of the left-right limit in order to compute the derivative. Okay, you still need this technique. And one thing that we see is going to be sometime the function is continuous nicely, but it's not, the derivative does not exist because of you're going to get a corner or a cusp, or sometimes you're going to get the vertical tangent line. Vertical tangent line is means slope equal to infinity. Equal to infinity or negative infinity. Okay, so there's a vertical tangent line is mean that, and you're going to have this continuity that you not be able to touch the graph anyway. Okay, so when you have the graph look like this one, you not be able to touch the graph because you not have the point to touch. Okay, so that's why. Okay, so that's it for this video, and we're gonna have the next one about the how to differentiate using the formula. So we're gonna learn how to dip constant, and we're gonna learn how to dip sine, dip cosine, dip e to the x next, and then we're gonna discuss about the formula for finding derivative of the sum, the difference, the product, the quotient of the function later. Okay, so that's all for this one.